Okay, hello Year 12. What we're going to work through today is 3F, and the topic's called Global, Maximum and Minimum Points. The word global, though, is used interchangeably with the word absolute. So sometimes we'll refer these to absolute maximum and minimums or global maximums and minimums. So the maximum and minimum turning points are not always the maximum or minimum points on a graph. The absolute maximum is the greatest value of a curve in that domain, and the absolute minimum is the least value of the curve in that domain. The absolute maximum or minimum are found by finding the stationary points first. The endpoints of the domain are then substituted into the original equation. The highest or lowest values are the maximum or minimums. I'm going to jump over into the OneNote into 3F and have a little bit of a look at some of the stuff that's in the textbook here. I thought this is a really good indication of what we're actually talking about. There's two graphs over here to the right, so let's have a look at the first graph there, the top one. Okay, so if you have a look at that graph, what you'll see is there's a maximum at point B, okay, and there's a turning point at point D. This point D here is what we would call the global maximum. It's higher than the other point, that's the maximum point, and there are no other higher points on that curve. So that's what we mean. It's the highest of all the high points, basically, or the maximum of all the maximum points. So that's our absolute or global maximum. If we have a look down here, C is a minimum. C is a normal minimum point, but we would not call C a global minimum because our graph continues from B down through A, and it continues down through E. We don't know how far it goes. It might go infinitely far. We haven't got a restricted domain. So although that's a minimum, that's not a global minimum. As opposed to the maximum here, D is the maximum point. We don't have the graph shooting off up above D anywhere. So global maximum, that's a minimum, but it's not our global or our absolute minimum. Okay, let's have a look at the second diagram down here. Okay, our second diagram down here has a restricted domain. So our domain is given from P to V. Okay, so we're from P and we're going down to V. Okay, so the graph doesn't continue down here. It doesn't continue there. So there are endpoints. So we're saying that there's a maximum occurring at R, a maximum point, a maximum turning point. There aren't any other maximum turning points in there, but our point T, which looks like it's the highest, has been omitted, so we've got U included in that. So U's a little bit higher than R, but it's not a turning point. So we'd call this a maximum. It's not going to be our global maximum. Now, if we have a look at the minimum values, our minimum values are going to occur at Q and at S. They're lower than our other endpoint at V and lower than any of the other endpoints there. So Q and S are equal values, and they're going to be global minimums because they're the lowest value within that graph, and they happen to be a minimum. So that gives us a bit of an idea of what we're looking at when we're looking at global or absolute maximum minimums. And let's go back to our OneNote, and we'll continue on from there. Okay, so let's look at our first example, and then we'll just go back and look at what it wants us to do and see what we need to do to work this out. So example number 1, find the maximum and minimum values of y for this function. So this function is y, and it's x squared minus 4x plus 2 in the domain minus 1 is less than x is less than 4. So that's really important. We're only looking in that domain. So if there's numbers that fall outside that, we're not interested in them. Okay, so let's have a look at what we have to do. The absolute maximum or minimum are found by first finding the stationary points. Okay, then the endpoints of the domain are substituted into the original equation. So that'll be these values here, are substituted into our original equation. The highest or lowest are the absolute maximum or minimum. So let's do that. Okay, so we need to find the stationary points first of our curve. So let's work through that and do that. So we've got our first bit of information. We know f of x is x squared minus 4x plus 2. Let's just straight away go ahead and find f dash of x and f double dash of x. It's nice to get it over and done with at the start. Okay, so our first derivative is 2x minus 4, and our second derivative is going to be 2. So we want to find our stationary points. when do stationary points happen? Do you remember when that happens? The stationary points happen when our f dash of x, or our first derivative, is equal to 0. Remember, that's when the gradient of the tangent at a point is flat. We don't have any slope to that. So that's when our stationary points happen. So if our f dash of x is equal to 0, we want 2x minus 4 equal to 0. That will give us 2x is equal to 4, or x is equal to 2. That is our x value of our stationary point. Let's find our y value. So when x is equal to 2, y, which is f of x, remember f of x is just y, is going to be equal to 2 squared minus 4 times 2 plus 2, which is 4 minus 8 plus 2, which is 6 minus 8, which is minus 2. So we have a stationary point at 2 minus 2. Okay, so now we have our stationary point. Let's figure out what the nature of that stationary point is. So the nature of our stationary point, I'll pop that in there, the nature of 2 minus 2, we are going to use our second derivative for that. Okay, so we're going to find out what f double dash of x is. We actually want to find out what f double dash of 2 is, because we want to know at that stationary point. And I've actually already got that value up here. That equals to 2, which is greater than 0. So it's positive. So it looks like this. So it's concave down. Sorry, concave up, not concave down. Concave up. And it's a minimum stationary point. Okay, so that's given us a little bit of information about our function. But what we're wanting to do, remember, is we're wanting to find what the maximum minimum values are. So we know we've got a minimum stationary point, but let's figure out whether or not our endpoints here, our minus 1 and our 4, are going to give us a value that's lower than what our stationary point is. And the only way we can do that is by substituting in minus 1 and substituting in 4 into our function up here. So that's what we need to do next. Let's just change colours. Another line in there so we can split it up. So let's pop in x is equal to minus 1. When x is equal to minus 1, we're going to figure out what y equals. And we're also going to figure out what happens when x is equal to 4, because that was our other value in our domain. And we're going to figure out what y is. So if you want to pause the video and pop your values in for that, I'll get mine in a second. Okay, so if you pop those back into your original function, we're going to get 7, and we're going to get a value of 2. Okay, I'm going to go ahead and draw that and figure out what we've got happening. So you can pick that in there. We've got an x, we've got a y. Let's see what we've got happening. Okay, so we know we have a minimum value at 2 minus 2, sorry. So there's 2 minus 2. So I know I've got a minimum happening here. Okay. I know that I have a maximum value. Not a maximum value, but a value of minus 1 and 7. So I know my curve goes up to here. Okay, and I know I also have 4 and 2. So another value that I've got happening here is 4 and 2. So my curve's going to come down through here. It cuts the y-axis when x is not, so it's going to cut the y-axis at 2 here. It's going to go through here. It's going to go down there. It's going to go back up here. And that's what my graph is going to look at. Now, let's go back and have a look what the question was actually asking us, because we haven't actually answered that question yet. The question was saying to find the maximum and minimum values of y for the function. So our maximum value is equal to 7. Okay, our maximum value of y is 7 up here. We're only looking for the function value. So y is f of x. So that's the y value we want. We want our maximum value. And our minimum value, what's that going to be? The minimum value of y is down here at minus 2. So the minimum value of y is equal to minus 2. And that answers that question. Okay. You probably may have been able to do that without drawing the function, but I think it's still a good idea to draw it just in case you have a different picture in your head of what it actually would have look like. Okay, so let's have a look at the second example. This one's saying find the maximum and minimum values of the curve y is equal to x to the power of 4 minus 2x squared, and we're looking in the domain of minus 1 to 2. So let's start with what we know. Now we know y is x to the power of 4 minus 2x squared. Let's find y dash. Y dash is 4x cubed minus 4x. Let's look for y double dash. That is 12x squared minus 4. So we've got our information. Now, before we can find these maximum and minimum values, do you remember what we need to do first? We need to assign a stationary point to those. So we need to find a stationary point. So let's do that. Remember, stationary points, turning points, they're all the same thing. They're just different names for that same thing. So a stationary point happens when dy dx is 0. I've called dy dx y dash. Okay, so stationary points happen when that is equal to 0. So we're going to have 4x cubed minus 4x is equal to 0. We need to factorize that. We can pull out a 4x. So we're going to have left x squared minus 1 is equal to 0. Just double check. We've got 4x cubed minus 4x. Yep, that looks good. In our brackets, we have a difference of 2 squares. So we're going to have 4x, x minus 1, x plus 1. We have a cubic, so we should have three roots generally there. So we've got x is 0, x is 1, and x is minus 1 are our zeros. They're our stationary points. The x values of our stationary points, we need to find our y values. So when x is 0, we're going to find what y equals. When x is 1, we're going to find what y is equal to. And when x is minus 1, we're going to find what y equals. So what you need to do to get your y values is pop each of these values one at a time into this function up here to get our y value. So when x is 0, y is going to be 0. Okay. When x is 1, y is going to be, not going to be 1. It's going to be 1 minus 2, which is minus 1. And when x is minus 1, we're going to have 1 minus 2 again, which is minus 1. Okay, so we've got 0, 0 as a stationary point. We have 1 and minus 1. And we also have minus 1 and minus 1 as stationary point. Now, before we can do anything else, we need to figure out the nature of these 3 points to decide whether or not we've got maximum or minimums or possibly even inflection points. So that's what our next step is going to do. I will change the color so we can see that that's our next step. So let's find the nature of our stationary points. And that's just finding out what type of stationary point it is. And how do we do that? We're going to use y double dash. Okay, so 0, 0 is our first one. So let's figure out what's happening to y double dash at 0, 0. So y double dash, or our second derivative, is 12x squared minus 4. Let's pop 0 in there. We're going to have 12 times 0, which is 0, minus 4. We're going to have minus 4. So that is less than 0. What does that tell us? Our stationary point goes like that. So it is a maximum point. Okay, let's find our next one. Our next point is 1 minus 1. When we pop our value for x, which is x equals 1, into the second derivative up here, we're going to get 12 times 1 minus 4, which is 12 minus 4, which is 8. And that is positive, so it's going to go the other way. We're going to have a minimum point there. Okay, if you're not remembering these, you need to go back and have a look at our notes from last lesson, and you'll need to memorize those. Now, at the last point, which is minus 1 minus 1, y double dash is going to be equal to, what have we got? 12 times minus 1 squared minus 4. Okay, minusing, scoring a negative gives us a positive, so we're going to have 12 minus 4, which is going to be 8 again, which is greater than 0, so it's going to go this way. It's positive, so it's going to be a minimum point again. Okay, so it hasn't answered our question yet, because what we need to do is not just getting us to find the maximum and minimum values on that curve. We're going to need to figure out, oops, just fix the OneNote up. Oh, that's a little bit better. We're needing to find the maximum minimum value. So we need to get our domain, which is between -1 and 2, and substitute those values into the curve to find our maximum minimum y values that occur when x is -1 and x is 2. And then we'll have a look at the graph and see what our actual minimum and maximum values on the curve actually are. That's our last thing we need to do. So we'll just change the color of our pen again. We'll go to bright green. So when x is -1, we want to find what our y is going to be. And then when x is going to be equal to 2, we're going to find what y is going to be. So we're going to pop those values, -1 and 2, into our original y value to get our y value. So if you want to pause that and get your values for that organised. Okay. So if we pop our values in there, when it's 2, we get 8. When it was -1, where are we? We've actually already done that one. Up here, it was -1. So I'm going to draw my graph and see what we've got and come up with a solution. So let's do that. Let's pop our axes up here and see what we can come up with. Okay, I might pop these minimum points on first and maximum points for the domain. So we know our domain is between -1 and 2. So when x is -1, y is -1. So I've got a value down here. When x is 2, y is 8. 8 up there. X is 2, y is 8. Okay, kind of working backwards here. We know 0, 0 is a maximum turning point. Okay, so we know we've got a maximum happening there. We know that at the point 1 and -1 we have a minimum. So 1 and -1 here, we're going to have a minimum turning point. And we know that at, what was our last one? -1, -1, it's also a minimum. So -1, -1 here. Oops. Might fix that first little point up there. We've got half of it there. Okay, so our curve's going to go up to there, down there, and it's going to go all the way up here. I'm sure you could sketch a neater one than that, but our graph is asking us what are our maximum and minimum values. So our maximum value happens when y is equal to 8. And our minimum value is at, I think there's 2 of them here. We've got one down here at -1, another one here at -1, is that y is equal to -1. Okay, so that's that one done as well. Go back to your textbook and have a go at the exercises that belong to 3F. And good luck coming back to class with any questions that you might have.